In this video, we are going to talk about algebra and algebraic expressions. So let's start with algebra. What's algebra? Algebra is a branch of mathematics that deals with mathematical symbols, and it also specifies rules governing how you manipulate those mathematical symbols. So algebra is a very wide concept, but in this video, we're going to talk about a small aspect of algebra, which is known as elementary algebra. So this is more or less like an introduction to algebra. So now let's talk about elementary algebra. Elementary algebra deals with variables. And in this video, we'll be talking about variables and how to manipulate them and how to express them and so on. So elementary algebra builds on top of basic arithmetic. It tries to represent numbers as variables. And there are a lot of interesting patterns we're going to be talking about. So let's get started. So let's start with algebraic expression. So the first thing, what's an expression? So I'm going to give you an example here. If you have 2 raised to the 2 times x raised to the power of 2 plus 5x minus 4. This is an algebraic expression. Now I'm going to break this down. An algebraic expression is made up of terms. So this is a term, this is a term, this is another term, right? So they are all terms. So in this expression, we have 3 terms. So an algebraic expression is made up of terms. A collection of terms make up an algebraic expression. So how do we recognize terms? Each term is separated by plus or minus. So if you have an expression of this kind, so let's say you have 2xy minus az plus 7, you know that this is a term because there is a minus separating, this is a term, and this is also a term. So this is an example of algebraic expression. So let's break down a term. Let's pick this 2x raised to the power of 2. If you look at this, a term is made up of symbols connected by times of division. So that's what a term is. So if I have something like 5yx divided by 7, this is also a term, right? Because you can't find plus, you can't find minus. So they are all connected by times of division. So what I mean by that is you can express as 5 times y times x divided by 7. So there's no plus minus here. So this is a term. So now let's break down what a term is made up of. A term is made up of a coefficient, although not all terms might have coefficient, but in this particular instance, this is a coefficient of this term. Then this is the variable, or this is a variable x. And this is the exponent of variable x, the exponent or power of variable x. So a term is made up of all this kind of, is made up of coefficient, variable, and the variable may have an exponent or a power. So what is a coefficient? A coefficient is just like a fixed number that you multiply to a variable. That's what a coefficient is. So if I have something like 5a, 5 is the coefficient of variable a. Now what's a variable? A variable is an unknown number or unspecified number. The powerful thing about algebra is it takes a symbol and use that symbol to represent any arbitrary number. And by doing so, you can represent a formula with that concept. You can just use that symbol to represent an abstract object or a real object. And that is what a variable is. It's just an unspecified number. You just don't know what it is right now, but you are just imagining that that number is represented as x. So that's what a variable is. And a variable can have, what they even call it variable is this, the value can be specified when needed, and the value can have varying, the value can vary. The value could be 1, 2, 3. So that's why they call it variable. So that is what makes up a term. We've got a coefficient, we've got a variable, and we've got an exponent. But then there are certain terms that may not have exponent, or the exponent is 1. So in this case, the exponent is 1. So in this case, we don't typically write the exponent. So let's say, for example, I have 7x. It's the same as 7x raised to the power of 1. So, but when the exponent is 1, you don't write it. Then there are times when you don't see coefficient. So let's say I have y. Now in this case, the coefficient is 1, but we typically don't write the coefficient when the coefficient is 1. So then there are times you may have more than one variable. For example, you may have something like 3x, y, z. So here we've got 3 variables and 1 coefficient. So these are all terms. This is a term, this is a term, and so on. But there are terms that we call constants. For example, in this case, this 4 is a constant. It's also a term, but it's a term without a variable. So when you have a term without a variable, just a number or a fixed or a symbol that represents a fixed number, you call that a constant. So constants are terms with no variable. So this is what an algebraic expression is all about. So we're going to be talking about how to manipulate expressions like this shortly. So let's take a look at how to manipulate algebraic expressions. Let's talk about simplification and expansion of algebraic expression. So let's say you've got something like this: 5x squared plus 2xy minus x squared, then plus 7xy. Then if you are asked to simplify this, what do you do? So before we talk about how to simplify this, let me mention a concept known as like terms. So we've talked about terms earlier, and each of these are terms. This is a term, this is a term, and so on. What are like terms? You say two terms are like terms. In other words, you can say they are alike if they have the same variable and each of their variables had the same in terms of exponent. So two terms are said to be alike when they have exactly the same variable and the exponents of their variables are the same. So think about it this way. So if I have something like AB and 7AB and 5AB, they are all like terms. They are very much alike. Why are they alike? Because they have the same variable, AB, AB, AB. But then if I have A square B, this is not alike. It's not alike when compared with this 3 because it's not like the 3 because the exponent here is not the same as the exponent here, it's not the same as this. So this term is not a like term compared to these 3 terms. So if you have another example like this, so let's say I have something like 5mn squared and 3n squared n. Okay, if you look at this carefully, you'll see that we have n raised to the power 1, m here raised to the power 1, n raised to the power 2, n raised to the power 2. So you see that these two, they are very much alike. The coefficients, the variables are alike, but the coefficient might be different. So because they have the same variable, you call these like terms. So when simplifying expression, what you want to do is to add or subtract like terms. That's basically what you want to do. You want to identify terms that are alike and add them. And you add them just the way you add in arithmetic, just the way you do your addition, your subtraction, and so on. So that is how you simplify expressions. So let's take a look at this expression. So if you look at this expression, you will see that 5x squared has a term that looks like it, which is x squared. This x squared can be imagined to be 1x squared. So we bring this together, 5x squared minus x squared. So you just take this minus x squared. Then you take this plus 2xy plus 7xy. They are alike. If you check it out, xy, xy, just the coefficients are different. So let's subtract. I told you if you don't see any coefficient, the coefficient is 1. So which means you can treat this as 5x squared minus 1x squared. So how do you add or subtract in algebra? You treat the similar coefficient like an object. So you take 5x squared, you have minus 1x squared. You will treat this x squared like an object. So imagine this is an orange, for instance. So it's as if you have 5 oranges, right? Then imagine this will also be an orange. So this is like 1 orange. So if I ask you what is 5 oranges plus 1 orange, you tell me it is what, 6 oranges. So that is basically how you add or subtract like terms. You since they have exactly the same variables, you just focus on their coefficient and just add or subtract. So in this case, it is 5 minus 1, sorry, which is 4 oranges since we are subtracting, right? So 5 minus 1, which will give you 4. So you treat it as 4 oranges. So now we have 4x squared. Then you take this coefficient, mind the sign you see here. This plus 2 is attached to the coefficient. So plus 2 plus 7, that gives you plus 9x and y, xy. So this is the simplified version of this expression. So this is how you simplify expression. So let's take another example. So let's say we have 11ab plus ab squared minus 3ba plus 7a, then minus 3b. So let's say we want to simplify this. So how do we go about it? So the first thing I want to do is to identify terms that are alike. So where can we find just AB? If you check, there's AB here, but the order is reversed. Even if the order is reversed, it doesn't really matter because A times B is the same thing as B times A. So because they are like, you bring them together. 11AB minus, you take the sign alongside with it, minus 3BA, then plus AB squared, that's this particular one, plus 7A minus 3B. Now, because there is no term that is similar, that is alike, you just retain all of this. So this becomes 11AB minus 3BA, which can be written as 11 minus 3, which will give us 8. Then just take AB. You can write it as AB or BA, it doesn't really matter. Then plus AB squared plus 7A minus 3B. So this is how you simplify this expression. Now let's talk about expansion. How do you expand an expression? So let's say you have 2 into brackets xy plus x minus y, and you are asked to expand. How do you go about this? Expansion just involves you multiplying whatever you have outside this bracket to everything you have in the bracket. So what this means is you take whatever you have here and you multiply to each of these items. So you say 2 times xy plus 2 times x minus 2 times y. And that you can write as 2xy plus 2x plus 2y. So that is how you expand. So let's take a look at another example. So let's say you have something like 3x into brackets y plus x. So let's say this 7x, and you're asked to expand this. How do you go about it? Okay, so what you do here is you do the same thing. You just take this 3x, multiply by y, which is this, plus 3x. You multiply to what? 7x. Now, how do you deal with this? You just, since x and y are different, you just take it as 3xy. Then, in this case, since you first multiply the coefficients 3 times 7, that will give you 21. Then x times x. Now you can write it as x times x, but eventually you need to simplify further. And to simplify further means you write it as x raised to the power of 2, because if you apply the law of indices, you just, since they have the variable, you just, and you're multiplying, you add up their powers, and that gives you this. So this is how you simplify. So let's look at another example. So let's say I have minus 5ab into brackets 2a plus 7b. So how do we go about this? So let me make this minus 7b instead of plus. So minus 7b, right? Now, what we want to do is to just expand. So, but this time you have to be careful with this minus. The same way we handle minus in arithmetic, that's how you handle it here. You just say minus 5ab times, this is, whenever there is no sign, it means plus 2a. Then you also have minus, so this is how you can deal with this particular scenario. You can say, you can put a plus here, then say minus 5ab times minus 7b. So I'm putting this bracket to make it clear when we do our multiplication. So what do you do here? You just take this coefficient and you multiply minus 5 times 2. That gives you minus 10. Then ab times a becomes a times a times b. I'm going to simplify further shortly. So here you take this minus 5, you multiply to minus 7. And you know, in an arithmetic, if you multiply two negative number, you get a positive number. So it becomes plus 35. Then you have a times b, which is ab, then times this b. Eventually, you're going to get, because you have a, and they have coefficients of 1 and 1, it means you can just take a raised to the power of 2, just add up their coefficients, then you have b, then plus 35a. Then since you have b and b times b, you just add up their exponents, and that gives you 2. Okay, so that is how you simplify an expression, like that's how you expand an expression like this. So we'll talk about factorization. Let's look at another interesting example of expansion. So this time around, let's say we have two expressions that we want to expand. So here we have x plus y, one multiplied to something like, let's say a, okay, let's use x this time around, minus 2y. So this is what we want to expand. In the previous examples, we are dealing with a term multiplying an expression, but here we are dealing with two expressions now. We want to expand two expressions. So how do we go about this? So the rule here is this. You take each of this term and you multiply to the other expression. So what that means is you take this first term, which is x, you multiply it to x minus 2y. Then you take this other one, which is plus y, then you multiply it to x minus 2y, the same expression here. So that's how you expand when those two things you're expanding are expressions. So what do? You try to expand further and simplify. So now that we have a single term multiplying an expression, a single term multiplying an expression, you just go ahead to multiply. So you just say x times x. So that will give you x squared. X squared, why? Because I'm multiplying x raised to the power 1 times x raised to the power 1, which is x raised to the power 2. Then minus x times minus 2y. So that gives you minus 2xy. Then you have y times x. That gives you xy. Typically, we write them in alphabetical order typically. Although it doesn't matter, you can say yx or xy. Then y times minus 2y will give you minus 2y times y. That's y raised to the power of 2. So the next thing I want to do is to simplify it. Try to look for terms that are very similar. If you can find any, you add them up or you subtract. So let's see. Can we find x squared here? No, there's no x squared. Can we find xy? Yes, we can find another xy. So we're going to say x squared. So we'll combine these two. If you can't find a coefficient, just know that the coefficient is 1. So here you have minus 2 plus 1. And minus 2 plus 1 will give you minus 1 xy. You will just write the same variable xy. Then the last part is minus 2y squared. So what we did was to combine these two to get this. Now, because the coefficient is 1, you just knock it off. So you don't need to write the coefficient if the coefficient is 1. So this is how you expand this kind of expression. Now let's talk about factorization. So how do we factorize expressions, algebraic expressions? So let's take a look at an example. So let's say we have something like this. We have 2xy plus 8x squared. And if you are asked to factorize this, what are you supposed to do? So factorization involves you taking out common factors. So the word factorization means you look for the common factors, then you take it out. So that's what factorization involves. So when we say look for the common factor, what I'm saying is look for the common factors in each of the terms. So here we have two terms, right? So what is the common factor? So you want to look at the coefficient first. What is the factor? What is the common factor between 2 and 8? The common factor is 2. 2 can go in 8 in 2 and 2 can go in 8. So you bring it out. Between the variables, that's xy and x squared, what's common? Mind you, x squared is x times x, right? And xy is x times y. So if you check this out, you will see that x is a common factor. So you can bring out x. So now, if you divide this, that is 2xy, you divide by the common factor, which is 2x, what are you going to be left with? You'll be left with y. So you just take this whole thing, divide by the common factors, by the common factor, then what you'll be left is y. So you write y. Then plus, you take 8x times x, that's x squared. X squared is x times x. And divide by a common factor, that will give you 4. X comes out x, so you're left with 4x. So this is 4x. So now, this expression has now been factorized into this. They are equal, so we can say 2x into bracket y plus 4x is equal to 2xy plus 8x squared. So these are the factors of this expression. So the two factors are 2x and y plus 4x. So that's how you factorize an algebraic expression. Although there are more complex cases where you have to apply some special techniques. So I'm not going to talk about those special cases here. Some of those techniques may involve you dealing with quadratic expression and so on. But we'll revisit factorization later on when talking about factorization. So this is an introduction to algebraic expression. We've talked about what is an algebraic expression. We've introduced what a term is and what constitutes a term. Then we talked about how to simplify an expression and how to expand an expression, and finally how to factorize an expression. In our next video, we'll talk about equations and we'll dive deep into linear equations, quadratic equations, and systems of equation, which is otherwise known as simultaneous equation. So see you in the next video.